Hello everyone, and welcome to the online statistical lectures. We're up to topic 5, which closely links to topic 4, hypothesis testing and one sample t-test, but now we're learning two new t-tests, the dependent and independent samples t-tests. Let us review a little bit what needs to be in your head when you're learning this new material. These two kinds of t-tests. Hypothesis testing and its basics, and the one sample t-test as given in lecture 4. So what is the null hypothesis, for example, and what is the basis of this whole inferential statistics that we're doing here? Well, the main idea that we set up a null hypothesis, we're going to do that for each and every test, and it will be different for each and every test. And we assume this H null to be true unless we prove it wrong by statistics. For the one sample t-test, we had a mu null, a pre-given value, and we compared that to the estimated population mean that we sort of concluded from the sample that we took. These are the alternatives, and of course we have in mind usually one alternative that we want to become true. So another reminder, I'm just quickly going to roll through this, but please read it in the other lecture or listen to it, is that what are the types of errors we can make. We can do the same types of errors in the paired samples and an independent samples t-test as we discussed in the one samples t-test. Another reminder is that, and a little practice. So if I choose this value for the level of significance, the usual 5% value, my probability for the type 1 error is 5% or even smaller. My confidence is such, but if I choose a more strict rule to begin with, it will be just 1%, and anything above the 10% is a tendency. This is new information, it's quite important. Any p-value above the 5% is not significant. That's a very important issue. Even if it's 5%, it's not significant. It has to be lower than 5%. And this is just some examples that most statistical programs will provide you with an exact level of significance. Okay, and of course this is significant, this is not significant, above 0.05. This is not significant, but there is a tendency, okay, we're at this point, and not significant. Please practice these. It's evident, but still it needs some practice. Also a reminder how to do conclusions. Okay, we already talked about this in topic 4. But now let's compare the means for dependent samples. What are dependent samples? We will cover that here. And this test is also called the paired samples t-test or the dependent samples t-test. It varies on who is using which term. So we will talk about these dependent samples, the direct difference method, the way to calculate these, the degrees of freedom again, and the errors again. We already talked about these. Now, what is the null hypothesis for the paired samples t-test? Here we have conditions. We have a usually before and after, or summer or winter, so anything that has to do with the same observational unit. And our null hypothesis is that the estimated mean in the two conditions, which is derived of course from the sample mean, is equal. So we have to collect enough evidence to prove that they're either condition 1 is higher as a mean value or condition 2. Okay, so we're aiming at these two alternatives when we're doing this test. let's begin by stating what are dependent samples. Well, if you have observation from one sample that's related in some way to another, then you have dependent samples. Typical is the repeated measures design, where you have data from the same individuals as noted before, for example, in a condition 1 and in a condition 2. You can also do what we call a matched subject design, where you have a set of subjects that are important and you select pairs for them. One typical of this is that if you have a, let's say, any sample who is in the clinic, so clinical samples, then, for example, you're choosing the spouses, same age, opposite sex, so they could be good pairs, but it's always a question of the actual problem you are doing. Or any other case when the observation, the units of the observations are not independent. For example, twins, husbands and wives, mother, son, etc., etc. So let's do a little test. Is it dependent or independent samples that we're talking about? If it's IQ scores for twins, well, that's dependent, obviously. Females and males of a school, on the other hand, are independent. They have nothing to do with each other. But students who sit together in the classroom are dependent because they sit together. So that's a criteria that connects them. And easy pulse rate before and after chemotherapy is a typical dependent samples. This also is worth practicing. How does a case variable matrix look like for dependent samples? So we usually have a set of subjects and then a condition 1 and then condition 2 in the columns. For these conditions, we will calculate a difference score, and these are the scores here, and that's what the statistics will be based upon. Okay? So this is the direct difference method. It's not a big deal. You can do it, practice it, and the t-tests use this as the values for input. Because in the t-test, okay, we will have this mean of differences and the standard deviation of the differences, and we will use this very simple formula to have the mean and then divide it by the standard deviation of the different scores divided by the square root of the elements. Of course, here we mean pairs by the n. So we always have criterias. They have to be quantitative, normally distributed variables, and the standard deviation of the two conditions should be similar. And SPSS will calculate the different scores for each pair and all the rest. All you have to do afterwards is check the results. Basically, you don't even have to check the critical values because not only SPSS but JASP and its statistical program will give you the end value. But for the sake of understanding, let's look at how this goes. Most importantly, the conclusions are made for the pair. Okay, so the twins, the couples, the conditions, etc., etc. So a generalization of the hypothesis testing we did already in lecture 4 is that we take this t-test result, we have two critical values that we will either look in the table or trust the program to do it for us. But it's very important that just like in the one sample t-test, we don't have a fixed value here bordering the region of retention. We have to actually come up with these numbers somehow. Okay, so let's do a practice. For example, typical t-test material. Do you think it's more difficult to recall words in English that start with vowels or consonants? What do you think? Let's stop for a moment because it's an interesting point. You might have a different opinion. And remember, it's English. It might be different in different languages. Please do this task, design an experiment, etc., etc. Stop the video for a moment and then look, because you already know how to do these things from the first lectures. Okay, so my statement might be, is it easier to recall words in English that start with vowels or consonants? Experimental design, don't forget units of observation variables. Research hypothesis should be that estimated population mean of recalling English words with, let's say, consonants will be significantly higher or lower based upon your opinion than the estimated population mean of that for vowels. Okay, and this is the statistical hypothesis. I choose this one for consonants being better because there are more recalls, let's say, under a minute. So this is the experiment that could accompany this hypothesis. Half of the group could recall as many words as they can in English starting with consonants. Remember, you have 1 minute. You might even try it out. The other half of the group could recall words with vowels. Okay, similar 1 minute. What could happen in this respect? Okay, we still have to switch the tasks in order to have data for both vowels and consonants. And it also helps us the order effect. When you're doing the task, you're getting better and better and better on it. So that will eliminate this factor. Okay, you can calculate the different scores for the raw data. And I have a little Excel attached to this file in the Google Drive or this lecture, in which you can check an example of these results. The difference variable is calculated here in this column, and also the mean and the standard deviation for this column is calculated in the Excel, from which you can do a t-test by just hand, but also in the Excel I've given the t-test formula so you can check your calculations. Getting back to hypothesis testing, your decision is always based on this. You have a t-value, which if calculated well, it should be 2.5. Then you have a degree of freedom, okay, and that's 15 based on how many observational units we have. And we have to set up this critical value, okay, which if checked in the Excel, either in a sheet or a table, but also some formulas can calculate this value. It's this for this degree of freedom. So these are the average recall numbers for the vowels and the consonants. So which was easier? Consonants. Probably there are more words with consonants. You also have to report the standard deviation and other important details, which is summarized here in yellow. So if we're talking about foreign language students, that's where I derive my samples from, and they're recalling words in English, starting with vowels and consonants. This is the performance we get, or I got, from the 16 students. And my conclusion is that consonants were more consonants were recalled as compared to vowels, which is based on the t-test. I've given all the parameters of the t-test that are important. Is it significant? Yes, the p-value is below 5%, thus we've found a significant difference here. Okay, let's stop for a moment because it's very important to decide. So far we have a one sample t-test and a dependent sample t-test and also a z-test in hand. So this is just a summary of how should we decide on which to use. So basically you can use a z-test or a t-test if you know the sigma. Okay, you can still use the t-test if you know the sigma, but you're also allowed to use the sigma in the z-test. When you have a pre-given value, okay, a menon, that's the story. Here we did something totally different. We compared two conditions, basically. The vowel condition to the consonant condition. So let's practice this again a little bit. This is my problems. Do patients have a higher pulse rate before the chemotherapy than after? Obviously, the answer is pretty straightforward. And these are my other questions. So please try to answer them. Okay, we can get back to the answers in the conclusion, in the discussion part. Okay, so this is our next big topic, the t-test for independent samples. And here we have to differentiate dependent and independent samples. It's not that straightforward, although if you get into the practice of it, it will be no problem. And homogeneity of variance and effect size is not obligatory material. I will glance it and you can read the relevant chapters. So for independent samples t-test, we keep the same logic, only here we have group values to compare. So we will have a big group for my, let's say, male group compared to the female group could be a typical example. Story is the same. We have to collect enough evidence to reject the null hypothesis. And before going into more details, let's see Mrs. Rocky and her partner, Mr. Rocky, and let's take a little stroll along the way of dependent and independent samples. So we have all these people who will accompany us in our quest, and we are going to make groups of them for our database. So if we, if we group them as such, then I gave it away. Sorry, they are dependent samples. Okay, why? Because they're related. Okay, we have the Smiths, the Tutis, and the Rockies. Can we talk about males and females? Yes, of course. But we have to conclude to couples, okay, who are husbands and wives and males and females. That's perfectly okay. Okay, this is how the database will look like. Remember, we have data for the wives, data for the husband. Even though they're different people, the Rockies will be our unit of observation here. Let's do another sampling. And we have two really big samples. We have all the people. Do we? What kind of sample is this? It's also a dependent sample, only bigger one. Okay, no surprise there. How about this one? Okay, erroneous sample. Why? Because we do have pairs, but these two girl and guy does not match. We would have to have Mr. Rocky. So either we'll leave them out, but it would leave us two people. It's not a good idea. Basically, you have to solve this issue somehow. You cannot have, a few of the data not falling in line with the rest of it. Make it either dependent or independent. Okay, this is an interesting one. A typical independent sample. Question: can we talk about males and females, the group of males compared to the group of females? Of course. Can we talk about wives and husbands? Well, the trick is we can. They're just not each other's wives and husbands. Still, they are wives and husbands. Let's watch out in the conclusion that we're not concluding about the couples, but we're concluding about wives and husbands, independent groups. And this is how the data matrix will look like. We have what we call a grouping variable, male or female, usually given by numbers, and the IQ score as the main variable. So what is this sample? Again, problematic because we're missing Mrs. Small. So either get rid of Mr. Small or get in Mrs. Small, the picture. If it's done like this, it can be a nice dependent sample. Okay, so when we're testing independent samples, we have two random samples selected from two different, it could be subpopulations, but they are different populations. Okay? Question is if the differences we see are due to just variability of the population, or is the difference is due to the random selection and not larger than the variance of the individuals of either population. If this second case is true, then we don't really have a significant difference between the group. But if the difference is due to the specifics of that subpopulation, then it's a true difference. So we will test the null hypothesis that in fact mean of these estimated population mean of these two populations is equal, and then we do the hypothesis testing the usual way. So let's go back to our previous experiment with the vowels and the consonants, and let's use this data set with an extra variable. We also recorded if they were males or females, those who recalled these words. Question is now, very obvious question, could male and female performance be the same, or is it different? What is your assumption? We can have, again, a case variable data matrix. This is the same example Excel I showed you before, but we also have this variable noting whether they were males and females. Now, when we put this data in SPSS or JASP or any other statistical program, we could run an analysis with the grouping variable for vowels, for consonants, but also for this difference. So the effect that we have just seen for the dependent variables, the difference is the consonant, the more easy recall for consonants, is there a difference, a sex difference in this effect, in this consonant effect? So intriguing as that, I've checked all of these hypotheses in an SPSS analysis, but the same outcome could result from JASP. And here is what we found. Okay, we should look at the means and the standard deviations and also this level of significance. So obviously there's no difference for the vowels. There was a tendencial difference for consonants, and the interesting part is for the difference variable. But let's see this in details, okay, how to conclude these results. First of all, state about your observational units, then about the statistical test, and then you can show that males are better at recalling consonants with some data as compared to females. And also, your homework is to conclude on the difference variable, and we can also discuss it. The last quest, which I'm not going to do here, but I recall upon you to try to do it at home after you review this lecture, is choosing which t-test to use for these specific problems. Okay, you can find the answers in the PDF, but I urge you to do it by yourself. Thank you very much, and see you on the consultation time.